In this next video in my A-level chemistry series, I'm going to show you how to answer an extended exam question on acid buffers. This 6-mark question does not consist of 6 individual marking points, but instead your examiner will mark the whole question and then decide which level of response you have given, whether it falls into the 5 to 6 mark category, 3 to 4 or 1 to 2. If I was reading this question for the first time, I would be noting the following information, maybe underlining it or highlighting it. So, HNO2 is the weak acid. The pKa value is 3.34, so maybe we need to convert that to Ka shortly. That the weak acid is made by reacting N2O3 with water, so we maybe need an equation for that later. But there's only one product formed in that reaction. That there are 2 steps to this reaction. So the N2O3 is weighed, then water is added to it, and then in step 2, sodium hydroxide is going to be added to react with that weak acid, and the resultant solution made up to 1 decimeter cubed. The actual question is at the bottom, and we can see it's in 3 parts. So we're going to explain why a buffer solution formed in step 2. We're going to find the pH of that solution and the initial mass of N2O3 that was used in step 1. So let's explain why a buffer solution forms in step 2. It is essential that you have your own copy of the specification to refer to during the course. This will be very useful when you come to revise, as you can check that you have covered all aspects of the course. There are 2 methods for making a buffer solution mentioned in your course. The first one is where a weak acid is simply mixed with its salt that contains its conjugate base. There's no reaction between those 2 solutions. This question refers to the second method, where a buffer solution is formed from an excess of weak acid and a strong alkali. There is a chemical reaction between those 2 solutions, forming the salt that releases the conjugate base, but some of the weak acid remains because it was added in excess. Your examiner will therefore be looking for the following in your answer. You must use the word excess when referring to the weak acid or nitrous acid. You need to say that it's partially neutralized by sodium hydroxide, which is the strong alkali. An equation is useful at this point, but not entirely essential. So you can see an acid and an alkali react to form a salt and water. So the resultant buffer will contain nitrous acid because it was in excess, so some remains, and you need to say something about the conjugate base, which is the nitrite ion. Or you could say the name of the salt, which releases that ion, sodium nitrite. You do not need to say anything about the sodium hydroxide, but recognise that there will be none of it in the buffer that has formed, because all of it will have reacted with the weak acid. Weaker students, however, would now start talking about the sodium hydroxide as the conjugate base, which is incorrect. It is the nitrite that is the conjugate base. At this point, weaker students would probably start to talk about how a buffer works, as that is frequently asked in exam questions, but this one does not require that. So the second part of the question requires the determination of the pH of the buffer solution formed. To do this, you will need to identify the amount in moles of each component in the resultant buffer. So note that the amount of acid that was added initially will decrease, but some of it will remain after the reaction with the strong alkali because it was added in excess, as previously mentioned. Secondly, there will be no strong alkali in the buffer solution because it all reacted to form the conjugate base. Thirdly, the amount of conjugate base will be exactly the same as the amount of alkali added in OCR questions, because for these questions the reaction will be between a monobasic acid with one H plus and an alkali containing one OH minus ion. So to find the number of moles of acid in the buffer solution, we first need to calculate the initial moles of acid added. This is just a simple concentration times volume calculation, but please make sure you include your units if you want to score the highest marks. Some of this acid will then react with the alkali that is added, so we need to calculate those moles, and then we need to calculate how many moles remain in the buffer, which is just the difference between them. Remember, the moles of the conjugate base will just be the same as the number of moles of strong alkali added. Now that you have calculated the number of moles of each component of the buffer, we need to calculate H plus concentration to be able to find pH. Now, we need a Ka expression to do that, which we rearrange to make H plus concentration as the subject. We also need to convert the pKa value given to Ka, fairly straightforward. But this next part is where some students get confused. We've calculated moles, but we need concentrations to substitute into our expression. Now, it's okay to do that conversion and divide each number of moles by the total volume to give concentration, but that's not actually required. For those of you with a bit more mathematical knowledge, you can see that in the expression we would be dividing the number of moles of nitrous acid and nitrite ion by the same volume. So those volumes would actually cancel and we can just use moles instead. And then thirdly, we calculate the pH from the H plus concentration. You're used to doing this, it's quite easy, but you would be amazed at how many students forget to actually do this stage and just quote the H plus concentration as their final answer. Some will also forget that pH values should always be quoted to 2 decimal places unless stated otherwise. So finally, we need to determine the mass of N2O3 used in step 1. This was the solid dissolved to make the nitrous acid. We've already calculated the moles of nitrous acid as 0.05, and we are told in the question that the N2O3 reacts with water to make a single product, the nitrous acid. An equation is very useful at this stage to avoid mistakes, but it's not essential. You could just state the ratio, although this is where some students will probably make a mistake. You can see in the balanced equation that it's a 1:2 ratio between the solid and the nitrous acid formed. So we will have half the number of moles of N2O3 compared with the moles of nitrous acid. So simple calculation gives 0.025, but we need to quote our final answer in the requested form, which is mass. So if we know the moles, we just need to multiply by the relative formula mass, which you can think of as having the units of how many grams are in 1 mole. So you can work that out using your periodic table as 76, giving a final answer of 1.90 grams. Now, it's good practice to include your units in your working and show all of your different stages in your calculation, because this will otherwise limit how many marks you can score on a question such as this. Using units also helps you to think logically and to quickly check your answer if there is time at the end of the exam. So what is an examiner looking for when awarding marks in a question such as this? There are a maximum of 6 marks available, but the examiner is not looking for, say, 6 ticks. What they are looking for is for the best fit for your answer overall. So for your answer to be in the top category of 5 to 6 marks, you need to have tackled correctly all 3 parts of the question. That is, the formation of the buffer pH, and the correct mass of N2O3. You may actually have made some small errors. That's okay. But your answer needs to be very clear and logically structured. You need units. You need to show you're working out. For 3 to 4 marks, it may well be that you've only tackled 2 parts of the question to the same standard as someone in the 5 to 6 category. It may well be that you've tackled all 3 parts, but with omissions, there may be some small errors, you may have missed out units. It may be difficult for the examiner to follow your answer. If you have really struggled to answer a question such as this, the examiner will still be trying to award you some credit. It may be that you've only tackled one part of the question, or you have various errors in all 3. But if there's some attempt and some line of reasoning in your answer, for example, you showed the relevant stages in the calculation, but you have carried forward errors, your examiner will give you some credit. For other A-level resources and help, please see my website science123.co.uk. For other A-level resources and help, please see my new website.